afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. In this video, we are going to discuss about minimum cost spanning tree. So, what is a minimum cost spanning tree? And we are going to discuss some example problems on minimum cost spanning tree. What are the algorithms to implement minimum cost spanning tree? All these things we are going to discuss in this video. So first of all, what is meant by minimum spanning tree? A minimum spanning tree is a connected weighted graph. What is meant by connected weighted graph means, for example, consider this is a graph. It is a connected because there is a communication line is present between the vertices of the graph. It is a connected. What is meant by weighted graph means some weight or cost. Some weight or cost which is present on the edges, then it is called as a connected weighted graph. So it is a spanning tree is a connected weighted graph, and some of the edges of the weights should be small or it is a minimum. So whatever the edge what we are going to select or it is a choose, that should be a minimum, then it is called as a minimum cost spanning tree. There are two algorithms to implement the minimum cost spanning tree. First one is called as a Prim's algorithm. Second one is the Kruskal's algorithm. The Prim's algorithm was implemented by Robert Prims in 1957, whereas Kruskal's algorithm was implemented by Joseph Kruskal in 1956. These two algorithms are used to find the minimum cost spanning tree in the given graph. So first of all, Prim's algorithm. So in the case of what are the steps we have to follow to find the minimum cost spanning tree using Prim's algorithm. First step is choose an edge with the least weight. That means suppose there is a graph, what the graph consisting of vertices and edges. So these are the weights and these are the edges. Edges and the corresponding weight. We need to choose an edge with the least weight. Among all the edges, we are going to select the least weight edge. That is 1 to 3 will be selected first. Whatever the edge that we are going to choose, that is included in the spanning tree. That is included in the spanning tree. Next, select an edge of least weight that is incident with the vertex of an edge in the T. What is an incident means adjacent vertex. Adjacent vertex. That means 1 to 2, 1 is having 2 as a adjacent, 3 is having 4 as a adjacent. Among 3 to 4 or 1 to 2, we have to select an edge which is the least weight and it should be an adjacent vertex. That edge must be included in the spanning tree. Among 1 to 2, 3 to 4, 3 to 4 having the least weight, that is included in the spanning tree because it is having the least cost. And also before adding in the spanning tree, we need to verify whether it is create a cycle or not. 3 to 4 does not create any cycle. That means there is no closed path for the particular spanning tree. Then we have to include it in the spanning tree. If it is any one create a cycle, just discard it. Repeat this process. That means adding the least weight edges which is a adjacent vertices. That process will be repeated for the n vertices and n minus 1 edges. So we have to select a least cost weight and it is included in the spanning tree. Next we have to choose an adjacent vertex which is having the least cost. This process is repeated for n vertices as well as n minus 1 edges. So for one graph there is a existing of more than one spanning tree with minimum weight. And also suppose the two vertices having the same cost, that is 1 to 2 is 2, 3 to 4 is also 2. Which edge is included in the spanning tree? We have to select either 1 to 2 or it is a 3 to 4. But the main objective is that should not create the cycle. You have to select any one. So we can understand this Prim's algorithm by considering some example problem. So this is an example. Here it is a connected graph, not only connected, but it is a weighted connected graph because there is some weights are present on the edges. That is a 10, 28, 14, 24, 25, 22, 18, 12, 16. All these are the what is a age. That is a cost. We can say that it is a weight. What is step number 1 in the case of Prim's algorithm? We have to choose an edge with the least cost. Among all the edges, the least cost is 1 to 6, that is 10 is included in the spanning tree. 1 to 6 is 10, that is included in the spanning tree. Next, what are the adjacent vertices of 1 and 6? Adjacent vertices of 1 and 6. 1 to 2 is 28, 6 to 5 is 25. Which is the least weight? 25 and 28. 25 is the least weight, that is included in the spanning tree. That is 6 to 5 is included in the spanning tree. Next, again 1 to 2, again 5 adjacent. 1 adjacent is 2, 5 adjacent is 7 and 4. So 28 is there, 24 is there, 22 is there. Among all the 3 vertices, which is the least weight? That is 22. That is from 5 to 4. That is to be selected as the next edge. And 5 to 4 does not create any cycle. So include it in the spanning tree in the step 3. That is 5 to 4 is included in the spanning tree. Next we after that 4. 4 adjacent is 7 and 3. So 7 is 18, 4 to 3 is 12 and 1 to 2 is 28. Among all the 3 vertices, the least weight is 4 to 3 and the cost is 12 is included in the spanning tree in step number 4. Step number 4, 4 to 3 is included in the spanning tree. Then what is the adjacent vertices of 3? That is 2. Then again 1 to 2 cost is 28, 3 to 4 cost is 16. I think 3 to 2 cost is 16, 16 is included. After that 2 to 7, 2 to 1. 2 to 7 cost is 14, 2 to 1 is 28. So 2 to 7 is included in the spanning tree. 2 to 7 is included in the spanning tree. After that 7 to 5, 1 to 2. So 7 to 5 create a cycle. So don't include it in the spanning tree. Then 1 to 2 also create the cycle. Don't include it in the spanning tree. Then we have to stop the repetition process because all the vertices are included in the spanning tree. Once we have to stop the process, then we have to find out what is the total cost of the spanning tree. How to find the total cost of the spanning tree? By sum up all the weights which are present on the edges, then calculating the total value, that is the total cost of the spanning tree. That is 10 plus 25 plus, that is 10 plus 25 plus 22 plus 12 plus 14 plus 16. That is 10 plus 25, 35, 57, 69 plus 30. That is 99 units. 99 is the total cost of the spanning tree. Now, second algorithm called Kruskal's algorithm. So, this algorithm was developed or implemented by Joseph Kruskal in 1956. In 1956. What is the difference between Prim's algorithm and Kruskal's algorithm? In the case of Prim's algorithm, we are going to concentrate on the adjacent vertices of the graph, which is having the least cost. Here, in case of Kruskal's, we are concentrating on the least cost, but it is not adjacent. We have to add all the least cost weight edges in the spanning tree, and we need to take care before add it in the spanning tree. What is the objective? Means you should not create the cycle, you should not form the cycle. What is step number 1 in the case of Kruskal's algorithm? Arrange the edges in G in increasing order. What is step number 1? We have to arrange all the edges according to the weight or it is a cost. That is a increasing order. Step 2. Choose an edge with the minimum weight. Among all the weights, among all the edges, we have to select an edge which is having the least cost or it is a minimum weight. That may be cost or it is a weight. We can call it in any term. Next. So whatever the edge that we are going to select, that edge is included in the spanning tree. That edge is included in the spanning tree. Next, add an edge of the least weight. Next, we have to select an edge which is having the least cost. If any one of the edge create a cycle, just simply discard that edge. Otherwise, we have to include that edge in the spanning tree. This process is repeated for this 4 step, and step number 4 and step number 5 is repeated for all the vertices. Suppose there is 7 vertices, we have to check whether the 7 vertices are included in the spanning tree or not. Once it is included, we have to stop the spanning process, and it contains 1 minus 1 edges. There are two important points in the Kruskal's algorithm. For one graph, there exists more than one minimum spanning tree. That is possible. And also, suppose the two edges having the same cost, you have to choose any one of the edge which is having the minimum weight. Consider the example for the Kruskal's algorithm, how to construct the minimum cost spanning tree using Kruskal's algorithm. So what is step number 1? Arrange all the edges according to the weight or it is a cost. Draw the two rows. First row is edge, second row is cost. So first edge is the least cost edge is 1 to 6, cost is 10. Next least cost is 3 to 4, cost is 12. Next least cost is 2 to 7, cost is 14. Then next least cost is 2 to 3, cost is 16. 4 to 7, 18. Next least cost is after 18, next least cost is 22, that is from 5 to 4. Next one is 5 to 7, 24, 6 to 5, 25, 1 to 2, 28. This is the step 1. Arrange all the edges according to the weight or it is a cost. After arrangement, we have to including those edges in the spanning tree which does not create any cycle. These are the vertices that are present in the graph. So what is the first one? 1 to 6. 1 to 6 is the least weight. So we have to add it in the spanning tree because it does not create any cycle. So 1 to 6 is included in the spanning tree. Next least weight is 3 to 4. Cost is 12. And it is also included in the spanning tree. Put the tick mark. Next least cost is 2 to 7. Cost is 14. It is also included in the spanning tree. Total cost is 14. Next list cost is 16. 2 to 3. It does not create any cycle. Include it in the spanning tree. 4 to 7. 4 to 7 can form the closed path and it create a cycle. Don't include it in the spanning tree. 5 to 4. 5 to 4. Total cost is 22. It does not create any cycle, so include it in the spanning tree. 5 to 7, create a cycle, don't include it. 6 to 5, include it in the spanning tree. Total cost is 25. Include it in the spanning tree. 1 to 2 also form the closed path, don't include. What is the total cost? That is the total cost is 10 plus 25 plus 22 plus 12 plus 14 plus 16. Total 35 plus 22, that is 57, plus 12, 69, plus 30, that is 99 units. This is the total cost of this spanning tree using Kruskal's algorithm. So what is step number 1? We have to write all the vertices in the step number 1. The least cost is 1 to 6. Next least cost is 3 to 4. Next least cost is 2 to 7 is included in the spanning tree. Then after that next least cost is 2 to 3. After that 5 to 4 is the next least cost. Then 6 to 5. After including all the vertices in the graph, so other edges can form the cycle, so don't include it. Then we have to stop the process and we have to calculate the total weight of the spanning tree by considering sum of all edges weight, that is 10 plus 25 plus 22 plus 12 plus 14 plus 16, that is total 99 units is the total cost of the spanning tree. So considering the second example, apply Prim's and Kruskal's algorithm for the following graph. So in the case of Prim's algorithm, we have to select the vertex. First one is Prim's algorithm. So in the case of Prim's algorithm, we have to select the vertex which is having the least cost. Here S to C cost is 2, D to E cost is also 2. We have to choose any one of the edge. That is S to C. Cost is 2. Cost is 2. Next, what are the adjacent vertices of S? S adjacent is B, C adjacent is 5. 6 and 5, which is the least cost, that is 5. So C to E is included in the spanning tree because it does not create any cycle. Cost is 5. Next, what are the adjacent vertices? S to B is there, then E to B is there, E to D is there, E to H. So compare this one, 6, 3, 2, 4 and then 3, which is the least cost, that is E to D is the least cost. What is the total cost of the spanning tree? That is 2. That is 2. Next, what are the adjacent vertices? B, S to B, then D to D, 6, 10. After that 3, 3, 4. Which is the least cost? We have to write E to B. Next, what are the adjacent vertices? That is B, 10 is there, B to S, 6 is there, E, then E to B is already written, E to G, cost is 3. It does not create any cycle, so draw the edge. Next, what are the adjacent vertices? 6 is there, 3 is completed, 2 is completed, 3 is completed, 4. Next, again for G, G to D, form the cycle, don't include G to H. Total cost is 3. Here all the vertices are included. S is included, B is included, D is included, G is included, H is included, E is included and C is included. So H to E form the cycle, D to G form the cycle, B to D form the cycle, S to D also form the cycle. Then we have to stop the traversing process, then to calculate the total cost of the spanning tree. That is total cost equal to 2 plus 5 plus 3 plus 2 plus 3 plus 3. 2 plus 5 is 7, 7 plus 3 is 10, 15, 18. 18 units. The total cost of the spanning tree using Prim's algorithm is 18 units. So in the case of Prim's algorithm, we always concentrating on the least cost which is adjacent. So for one vertex, any number of adjacent vertices may be present. Among all the adjacent vertices, we have to choose the least cost weight in the case of Prim's algorithm. The same thing we have to implement by considering the Kruskal algorithm. Kruskal. In the case of Kruskal, first of all, we have to draw the table which consisting of edges and the corresponding cost. Edge, then cost. Least cost is S to C, cost is 2, D to E, cost is 2, E to B, cost is 3, then E to G, cost is 3, D to G, cost is 3, G to H, cost is 3, then E to H, cost is 4. After 4, next highest value is C to E, cost is 5, S to B, cost is 6, B to D, cost is 10. So we have to draw the edges which is having the least cost. Now we need to draw the spanning tree by selecting the edges which is having the least cost using Kruskal. Using the Kruskal algorithm, we need to select an edges which is having the least cost. So write all the vertices that are present in the graph S, B, D, G, C, E, H. So among all the edges, first we have to include S to C in the spanning tree. So it does not create any cycle. Include it in the spanning tree. Sorry. S to C will be selected. Next least cost is D to E. Cost is 2. Next E to B. Total cost is 3. Does not create any cycle. Total cost is 3. Total cost is 3. Next E to Z. Cost is 3. It is also does not create any cycle. D to G. D to G form the cycle. Don't include it in the spanning tree. Next G to H. Does not create any cycle. Include it in the spanning tree. Total cost is 3. E to H. Form the cycle. Don't include it in the spanning tree. C to E. Does not create any cycle. Cost is 5. S to B create a cycle, don't include it. B to D also create the cycle, don't include it. What is the total cost of the spanning tree? 2 plus 5 plus 3 plus 2 plus 3 plus 3. That is equal to 5 plus 7, 10, 10 plus 6, 18, 18 units. The total cost of the spanning tree for using Kruskal's algorithm is 18 units. In the case of Prim's also, we got the same solution. What we have discussed up to now, what is meant by spanning tree, what is meant by minimum cost spanning tree, and we can understanding that minimum cost spanning tree by considering two examples called Prim's algorithm and Kruskal's algorithm. By using these two algorithms, we can understand what is meant by minimum cost spanning tree by considering some example problems also. Thank you.